Hello everyone, this unit is called Engineering Design Thinking. For this topic, regarding our design of a compressed air metal car, we will design a comprehensive conceptual design thinking. For example, the vehicle that we are designing must conform to the following four important basic design concepts. First of all, the vehicle must have sufficient structural strength to protect the safety of its occupants, and also fix in place all the systems for normal operation. Next is about power. Having an adequate and sufficient power source. Especially for the case of our racing cars, regarding its power, it would be great to have more power and improve the performance. Next is the vehicle's rolling resistance. For the axle systems and wheels, if it is possible to have a low rolling resistance, then the consumption of fuel and the loss of energy can be improved. Finally, the air drag of the car body design as the vehicle travels at higher speeds. The greater air drag affects the vehicle, especially for our racing cars. The decrease in air drag, whether it is to improve the loss of energy, the increase of speed, will both be greatly improved. Apart from the four aforementioned basic design criteria, modern cars, in order to fulfill more diverse expectations, these needs include having more space for the occupants, safer structure, reliable handling, and performance that meet the requirements. These multi-oriented standards have made the design of cars much more complex. Taking the example of the market's small-sized cars, if we disassemble all its components, there will be roughly 10 to 20,000 parts. Additionally, with the needs for safety and comfort, modern cars are basically so complex that they cannot be separated from a computer-controlled system. For example, the car that we see in this picture, there are many parts within. There are roughly over 20 miniature microcontrollers. So according to the product's requirements, each car has different features. There are a few aspects that we need to consider. For example, the loading of the car, its handling requirements, its driving power characteristics. These will differ greatly depending on what type of car you are designing. For example, the topic of this time's design, compressed air racing car. Our focus is on the design of a racing car. Regarding its loading, probably only one racer needs to fit in, so there is no need for large loading capacities. Regarding its handling, it requires very smooth handling and sensitive mobility features because racing is all about speed. Therefore, the requirements for power are very high. The aspects for the vehicles shown below, for the loading, handling, and power characteristics, they each have different considerations. For trucks and racing cars, the torque required for a truck is generally higher. It can reach a peak, especially at low speeds. Its ability to go up hills and carry heavy loads. For racing cars, higher torque and power needs to be achieved at high speeds. Under these conditions, competitions can be won. For the configuration of the power and transmission system, the design of the vehicle will have very different driving performance due to these configurations. For example, we should use these two concept images to explain. We will assimilate human power as the driving power. Pulling a baggage or pushing a cart is the vehicle we are driving. Everybody has had this experience. If you push your baggage or cart from the back or pull the baggage or cart from the front, the way of handling its stability will be different. If it is pushing from the back, such as a vehicle with front engine and rear-wheel drive, or with MR middle engine and rear-wheel drive, they have a similar concept. The driving force is at the back, and the center of mass is in front of the driving force. This type of drive may seem to have more stability and a more difficult handling. If the person is at the front, pulling the baggage or cart, it's like a vehicle with front engine and front wheel drive. Its handling is easier. So generally speaking, this design has better execution and is also more fuel efficient. But for a racing car, it will have different considerations, including its mobility and whether it can turn with a smaller radius of gyration. It will be designed with middle engine and rear wheel drive, or with rear engine and rear wheel drive. Looking at the design thinking from the vehicle and transmission configuration, we know that the vehicle design will prioritize the occupant's needs and loading space. Power configuration will vary depending on the features needed for driving. For example, the compressed air racing car belongs to the branch of racing car design. Our power is restricted to the use of steel gas cylinder and must be placed at the back of the vehicle to facilitate system activation and allow the racing car to run. So for the overall design of our vehicle, there is not much room for change apart from the height of the power source. As for the styling and structure, that determines the gravity. It will depend on the placement of our power source. Everybody can start thinking about what shape can allow our compressed air racing car to have an improved performance. Vehicle body shape and mass distribution symmetry. The symmetry for the vehicle's body shape and weight will be a key priority for us to consider. For example, if the vehicle's center of gravity is offset towards one side, its direction of motion will shift towards the lighter weight side, so it will be harder for the vehicle to keep moving straight. Its moving resistance will increase. In another aspect, vehicle's body shape symmetry, especially for strong incoming airflows. If the vehicle's shape is not symmetrical, it will also cause an issue of a deviation in the direction of motion. Dynamics of vehicle design. From the analysis of previous design considerations, we can understand that the vehicle's drive is subjected to complex forces. How to reduce resistance and increase driving stability and safety are important aspects to consider when designing the vehicle. For example, for the following illustration, we can see that the yellow arrow represents the vehicle's driving force. The vehicle's driving force is limited. How to reduce the influence of the other driving forces. Traction will be considered the important consideration. These forces, such as weight will increase the vehicle's driving reaction force. The increase in reaction force will continuously increase the vehicle's driving friction and will greatly increase the vehicle's rolling resistance. The rolling resistance is the vehicle's greatest force of traction at low speeds. Yet as the vehicle's speed gradually increases, air drag becomes the greatest force faced by the vehicle. Vehicle design, especially for racing cars, the reduction of air drag for the sports car is a very important task. From the illustration, we can see that as speed increases, the reduction of air drag becomes more important, whether it is truck, a sports car, or any kind of vehicle on land. The reduction of air drag is always an important design consideration. For the vehicle design aspects, apart from the product's performance, there are also other aspects, such as brand, shape, design, and style. Concept 1. Product positioning. Product positioning can be directly reflected on the design features. Product positioning is done through the analysis and comparison between other competitors' products within the market, and the survey and analysis about the consumer's needs for this product to establish the product's functions and the shaping of its quality. Concept 2. Brand image. Brand image requires a long-term accumulation of business experience. What people know about brand image is based on the brand's long-term ability and expectation to meet the market's functional needs, such as the establishment of a brand supporting group, the nationality of the production country, price, reputation, etc., which will affect the brand image. The picture on the right shows the long-term brand image of European car brands in the hearts of the consumers. All product development and the end phase of the design process may all need to consider its functions. And the analysis of product positioning. The analysis is first to understand the purchasing requirements. Each consumer has a value-oriented standard. Second is the analysis of the user's situation. On the graph, establish the competitor's market position. In this case, the different brands and cars. Next is to consider the product positioning for our product. In order to have better competitiveness, for example, on this graph, we can think, what features would be products in this area have? Would these features fulfill consumer expectations? Would they have competitiveness? Should we do further research and development for our product design for this area? Hello everyone, I'll be introducing you all to these engineering design projects, design parameters, measurement methods, and design features of the hands-on project for the compressed air racing car. Design restriction 1. Vehicle design shape. For the project on the compressed air racing car, we will broaden the vehicle design theme. For example, track-type racing cars, such as F1 racing cars or prototype racing cars, such as Le Mans racing cars or any other type of supercar, can be used too for vehicle design. I hope you can have a wider range for design production. Design restriction 2. Vehicle power. For the compressed air propulsion power, a PVC tube of 18 mm inner diameter can be used, or a 6 and 12 cubic centimeter steel gas cylinders. For the use of these two types of power, we can mix and match with different equipment and resources. For example, for the regular testing, maybe we use a self-made PVC tube propulsion system for final testings or racing competitions. Instead, we use a steel gas cylinder. Not only we can save resources, our testings and evaluations can be more comprehensive. Design restriction 3. Dimensions for vehicle design. For the project on the compressed air racing car, a standard dimension should be issued. For example, the car's length should be 200 mm. In other words, 20 centimeters. The car's height should be 50 millimeters or 5 centimeters. The car's width should be 80 millimeters, that is 8 centimeters, in order to allow room for optimization and improvements. The allowed tolerance is within 5 millimeters. Here the 5 millimeters refers to a 5 millimeters tolerance. So basically, we can exceed 200 millimeters car length, 50 millimeters car height, and 80 millimeters car width, but it cannot be smaller than the original dimensions. The purpose of this is to achieve fairness for the competitions. Also, regarding the dimension for the car wheels, we specify that diameter should be less than 40 millimeters, that is, measuring less than 4 centimeters diameter. Design restriction 4. Vehicle's minimum weight. For the sake of fairness, the restriction for minimum weight for our vehicle design should be over 150 grams. Another reason is for the structural strength of everyone's vehicle design to be enough to withstand the constant testings instead of being destroyed after a single test. Design restriction 5. Reasonable space for occupants. All vehicle designs must consider the space for the occupants. This includes racing cars. So for the project on the compressed air racing car, we must consider having enough space inside the racing car for the driver to fit in. The method for inspection is related to the vehicle design dimensions. For example, our car height must reach 50 millimeters. The car width must reach 80 millimeters. From the front view, within the range of 80 multi 50, we must reach 50% of the total area. That is 80 multiple 50 divided by 2, larger than 2,000 millimeters squared. Cross-sectional area. For example, in this picture at the bottom right corner, on the left is less than 50%, which does not fulfill our specifications for the racing car. On the right is more than 50%, which fulfills our specifications for the racing car. Restrictions are for everyone to develop their own design for the compressed air racing car within a reasonable parameter and have a comprehensive learning from our engineering design project. I hope everyone can do research experiments and related activities. The assessment criteria The assessment criteria for the course includes the four following parts. Number 1, the learning record file, which includes the student's vehicle design, notes, the problem definition, initial concept sketches, experiment records and performance evaluation reports, design drawings of chosen solution, production step description, problem-solving records, optimization improvement descriptions. The record file is our project's most important point of assessment, so it accounts for 40% of the total score. Number 2 is the crafting assessment, which includes the working attitude evaluation sheet and the tools operation and material choice evaluation sheet. This part accounts for 15% of the total score. Number 3 is written test. After the class, we will arrange an engineering design cognitive assessment, which accounts for 15% of the total score. Number 4 is the creation standard reference evaluation, which are the experimental data from 4 exploratory experimental activities. It accounts for 30% of the total score. All assessments are to guide the students towards the learning direction, especially for the learning of engineering design, process, and design thinking, while also allowing the students to explore their interest in the field of engineering and providing them with record files for further studies. Learning performance assessment. The 108 syllabus emphasizes on literacy-oriented teaching. The curriculum design and student learning performance assessment is important. Here is the assessment aspect. For life technology, it is to broaden the elective courses, learning objective, and the training method for our project activities. The table used as a reference is divided into knowledge, attitude, skill for our evaluation method. For the knowledge aspect, we use learning files to evaluate the student's engineering design notes, written evaluation, which is the assessment of the student's engineering knowledge. For the attitude aspect, we use written tests. For the skill aspect, we use learning files to evaluate the creations test performance results, the student's design sketches and models. For the integration capabilities aspect, we use learning files to evaluate and work attitude checklists. This is our curriculum assessment related to interdisciplinary knowledge application. For the 8 procedures in engineering design we have divided them into 4 assessment aspects. For the learning performance aspect, we evaluate students' hands-on performance in their project. To illustrate our students' knowledge application, the STEAM concept for interdisciplinary curriculum, a brief explanation of science, S, technology, T, engineering, E, art, A, and math, M. We shall give explanation for these knowledge applications. Next, I will be explaining to everyone the features of this engineering design course. The teaching project has the following 4 main features. Number 1, course designed to learn through a specific theme's knowledge and learning history. Number 2, emphasis on the integration of cooperation. Number 3, more time for autonomy and self-learning. Number 4, project orientation, serve as practical application of knowledge. These 4 characteristics are the main features of this hands-on project teaching. Students should make good use of all resources, show mutual help and cooperation with their design and production abilities, develop a spontaneous research and exploration habits through hands-on experience for the learn about design thinking abilities. Learning about problem solving in the production project. The project needs a lot of procedural knowledge, which must be learned through practical experience process. This procedural knowledge includes material processing and choosing, manufacturing equipment technique, 3D digital design application, digital analysis. They all rely on the students' practical experience to learn and develop problem-solving abilities. During the course of the project, there is much time for self-learning. Students must learn of ways to divide work and cooperate, forming a mechanism of mutual help and learning, and achieve effective learning. Design thinking is an internalization process during the experience of design production. Through these practical experiences, students can organize their own design thinking, application capabilities. Let's take a look at 3 project events and competitions related to vehicle design. First, let's take a look at this remote-controlled rubber band-powered car. This is for students majoring in engineering design and product industrial design to participate. The rule is to use a 15-foot long rubber band to make a remote-controlled and driven rubber band-powered car. The information about this competition is abundant. You can check the website provided on screen and search for relevant information as reference for learning. The second reference I would like to share with everyone is England's Land Rover 4x4 remote-controlled off-road vehicle project competition. This competition is for senior high school students to participate. Students need to make a remote-controlled off-road vehicle capable of challenging complex terrains and tasks. The objective not only is to make an off-road vehicle, but to also present a thorough design and production process. For competition resource, you can check out the websites provided by the teacher. The last project competition provided to you all is a compressed air car design competition organized by the F1 Association for senior high school students to participate. This competition is very similar to the air compressed racing car production in our course. This competition has a very long history, so the information is very abundant. Here we have developed this project competition into the learning content required for our engineering design process to serve as learning for our learning performance and design thinking. Students can check out more information about this competition for learning. Engineering design notes 2 define the problem and restrictions. Here we will regard to this week's engineering thinking related to the necessary concepts for the design of a compressed air racing car. The first concept is to reduce the car's weight and decrease its rolling resistance for compressed air racing cars. For the situation where there is a less weight, from the formula F equals ma, we can understand that at a fixed force, as mass decreases, this acceleration curve can reach maximum speed and momentum faster. This is usually an important aspect to consider when designing a racing car. The second concept is to reduce air drag and increase driving stability. These will be important factors to consider when designing our car. As speed increases, the increase in air drag will be considerable. So when designing our racing car, reducing air drag is extremely important. Relatively speaking, the degree of decline of this green curve will also be less and can reach the finish line at this red line sooner. The car's driving stability at high speeds is also very important. If stability is not enough, the related vibration and deviation will increase the driving time and causing a delay in the arrival to the destination. The design of a racing car is comprehensive. It needs to consider whether the structural strength is enough. The lower the center of gravity, the better. The less air drag, the better. The greater the stability, the better. These ideal design conditions are hard to meet. Students can try your best to develop your design thinking as well as knowledge related to engineering design with this topic for a comprehensive learning. At this stage, we will organize a car planning activity. Please plan your car body design inside this rectangular frame below. For the design of our compressed air car, our car's length, width, and height, maximum dimension specification is within this frame, so everyone can start with the wheels and axles within the range of the car's length and width. The car's height is drawn in this frame at the middle. A part needs to reach its maximum point. The car body contours relative position, including its shoulder line and waistline. You can roughly plan for it within this frame. Next, you can watch the following demonstration video. Engineering Design Notes 3. User Requirements and Market Research. Here we shall practice our design thinking abilities for product positioning. In this chart below, the vehicle design's economy and prestige is represented on the x-axis. Maneuverability off-road and on-road is shown on the y-axis. In these two dimensions, we analyze the car features corresponding to which position, making a product positioning segmentation. For example, this area slightly tending towards prestige and maneuverability off-road. What features would this product have? Let me give you two reference examples as hints. One is the Lexus LM300H commercial car. The other one is the Mercedes-Benz X-Class pickup truck. Everyone uses these two products to think what kind of vehicle design would belong to this area. Please write down your ideas within the lines in the learning sheet. Engineering Design Notes 3. Brand Image Planning. Each car brand will manage their products long-term to establish a good brand image in the hearts of the consumers, and also hope that through their logo, such image is deeply branded in the hearts of the consumers. For example, Toyota's logo symbolizes the heart of the users, and the car manufacturer connected blended in each one of Toyota's letters, T-O-Y-O-T-A, into this oval space. At the same time, this big oval shape represents the Earth, meaning Toyota heading worldwide into the hearts of every consumer in the whole world. The bottom right image is Hyundai's logo. The original logo hopes consumers and the business relationship like two friends shaking hands. After simplification, using Hyundai's letter H to further symbolize the relationship between Hyundai and its customers. Here we have arranged a brand image planning activity. Please design in the following box a symbol that uniquely represents your design.